Hey, feeling good, like I should. When in dark, I walk around the neighborhood, feeling blessed.
All right, let's take a look at our homework for lesson 7.2.1, starting with problem number 37. It says, would you expect a scatter plot comparing the speed of a car and the time it takes to drive 10 miles to show positive, negative, or no association at all? Right, so this is a little bit tricky. When you're trying to figure out if there is a correlation or an association between two variables, you kind of have to think about which one would be the independent variable and which one would be the independent. I'm sorry, which one's independent, which one is dependent, okay? And what I often tell students is you can control the independent variable, and usually the dependent is affected by the independent variable. So in this case, what are you taking control of? Are you controlling time, or are you controlling the speed of the car? And I would say you are in control of the speed of the car. Okay, so that's going to be your independent variable. And what we're trying to do is trying to see how the speed of the car affects time. So this is one of those rare situations where time is actually our dependent variable and goes on the y-axis. I would say most of the time we would put time in the as the x-axis or the independent variable, because you control how much time you spend doing something. But in this case, it's a little bit reversed. So it can be a little tricky. So let's think about this. This one requires us to think about the distance formula. You know, the distance that you travel is equal to the rate of speed that you're traveling times the amount of time that you spend traveling. So I set up this, and we know that we're going to go, the distance is going to be 10 miles, right? The time it takes to drive 10 miles. So that's going to be the distance. And we are going to change the rate of speed, and we're going to that's going then to affect the amount of time that it takes. So let's just think about this for a second. I've set up this graph where the time is in minutes, even though I want to think about the speed of the car as miles per hour, because that just makes more sense to me. And so I made 60 minutes. We know that's going to be 1 hour, right? And this is going to be a half of an hour. So I'm just going to put in 1 hour here and a half of an hour here to help us. Maybe I'll just put the 1 instead of the hour there. Okay, so maybe that'll help us a little bit. So if you're traveling at a rate of speed of 10 miles per hour, this would be, I would change this to be a 1. That means it's going to take, wait, hold on for a second. The distance is there. Your rate of speed is going to be 10 miles per hour. So when we solve for t, that means that t is going to be equal to 1 hour, which is the same as 60 minutes. So we would plot that point right there. Okay. Now let me leave that there. Let's come over here. We're still going 10 miles, but now let's increase our speed to 20 miles per hour. When we divide each side by 20, you would see that 1/2 of an hour is the amount of time that it's going to take. And so that would be 30 minutes. And so this point would go right here. We can do it a third time, and we could say we're going to go 10 miles, but this time we're going to go 30 miles per hour. So when you divide this by 30, this is going to give you 1/3 of an hour, which is the same as 20 minutes, right? If you break the hour into 3 equal parts, 60 divided by 3 is 20. So that point would be right around here, which would place our point right there. So you can see that the trend is, and that's terrible. Hold on for a second. No, stop it. Oh, wait, what am I doing? This goes, well, I don't need to draw the trend line. You can see where the trend line is going to go. It's definitely in the negative direction, so this would be a negative association. The faster you go, less time it takes for you to get someplace. So the time would be going down while the speed of the car is going up. So you've got one's a negative, one's a positive, so that's going to be a negative association. All right, let's move on to Oki, the western lowland gorilla who's living at a park in Boston. Many of his paintings have been sold because their colors are so interesting. One painting was sold for 5 times the amount of the second, and the third was sold for $1,500. If the total sale was $13,500, how much did the most expensive painting sell for? Well, this is interesting because I'm just right now teaching 5D process to my 7th graders. This is a review of the 5D process for you. So let's go through and make sure that we understand we've got a total of 3 paintings, right? So let's highlight these. It says one painting sold for 5 times the amount of the second. So it looks like the first painting is being compared to the second one. So let's make the second one X, and the first one would be 5 times X, which would be 5X. And then it tells us that the third one sells for $1,500, so we don't need a variable for that at all. So when you add all 3 of those together, for the second painting with the first painting and then the third painting, they add up to $13,500. So let's combine like terms and solve for X. Once you solve for X, you got 2,000, and then multiply that times 5, it's 10,000. So it turns out the most expensive one is the first painting, which was 5 times the value of the second painting, which is 5 times 2,000, which is 10,000. Now, I'll go ahead and solve this algebraically just to prove that this is correct. So when we take X plus 5X, you get 6X's plus 1,500 is equal to 13,500. And when you subtract away the 1,500 from both sides, remember to remove balanced sets. Whatever you do to one side of the equation, do the same thing to the other. This becomes 12,000. And on the left side, all you have is your 6X's. So what do you multiply times 6 to give you 12,000? Well, 12,000 divided by 6 is 2,000. And that's the work that you would show to get this for X. And now, let's just make sure that we've got everything correct. We're thinking that this painting sold for 10,000. This painting is selling for 2,000. And the third painting sold for 1,500. So when you add those together, if indeed add up to 13,500, which they do, we know that we've got everything correct and we can declare our answer. The most expensive painting was the $10,000 painting. All right, Mount Rose Middle School collected canned food to donate to a local charity. Each classroom kept track of how many cans it collected. The number of cans in each room were as follows. So this is the raw data. In order to create the box plot, we need to turn this into ordered data, okay? So first of all, the box plot was already created. So let's take a look. We see the minimum was 39, right? The maximum was 107. The median is 73.5. So when you put these order from least to greatest, the median is actually between 2 numbers. It's between the 70 and the 77. So the halfway point between those two would be 73.7. Let me actually pause this. I'm going to put those in order from least to greatest so you can see it. All righty, so I've got them listed from least to greatest. Least was 39, the greatest was 107. Now I'm going to count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Make sure I've got 10 in my order data. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, and so if there's 10, that means there's going to be 2 of them in the middle, and that's these 2 numbers right there. So you always want to find the halfway point between those 2 numbers, and the halfway point is 73.5. So to find the quartiles, you take everything less than your median, and there's your lower quartile. You take everything above your median, that's your upper quartiles, your 62 and your 80. All right, so what is the range of the data? Well, 107 minus 39 is 68. And are there any outliers? It's debatable whether the 39 and the 107 are truly outliers, but when you think about it, the distance between 55 and 86 is only 31, and the gap between 39 and 55 and the gap between 86 and 107 is pretty sizable compared to the gap between the rest of the data. So you can justify calling the minimum and the maximum, in this case, outliers. Okay? All right, I'm going to get rid of all of that, and let's take a look at Part B. It says for Part B that the main office staff collected 55 cans, the counseling staff collected 74, and the custodial staff collected 67. So So if we add that to this data and insert them so that they're in the ordered data, and this changes a little bit. You still have the same minimum, same maximum, but now you've got a total of 13 numbers, which means you've got a single number in the middle, which would be 70. All the numbers below the median, stop it, it's not what I want to do. And now you've got an even number of numbers here, so you got to take the halfway point or the average of those two numbers, which is 58.5, and then you take those two are in the middle, so you take the halfway point between those two numbers, and it's 79.5. So this is the new box plot when you include these three extra stashes of cans. All right, the trapezoids at the right are similar in shape, which means that there is a scale factor to be defined between them. So if we look to see the known sides, it looks like these are the known sides. Those are what you're going to use for your scale factor. We would either make the scale factor 3 over 5 because A is smaller than B, and so you'd multiply 50 times 6/10 or 3/5 to give you 30. But I could also say that it is 5 over 3, which would be the same as 1.6 repeated. So I would actually stick to the fractions when I'm doing this work. Okay, so let's see, X corresponds to 15 and Y corresponds to 18. So to solve X, I'm going to multiply 15 times the scale factor that's less than 1, which would be 3 over 5, and that gives me 45 over 5, which is the same as 9. So that would be 9 meters in length. And then when I'm going to solve for Y, I'm going to take 18 over 1, and Y is bigger than 18, so I'm going to multiply this times 5 over 3, which becomes 90 over 3, which is the same as 30. So the length of Y has to be 30 meters. Okay, so you just take corresponding sides, determine the scale factor as a ratio, and then decide whether you want to use the ratio that's greater than 1 or less than 1 as your scale factor as you are solving for the missing side lengths. Okay, Judy has $20 in, Judy has $20 and is saving at a rate of $6 per week. I'm going to highlight that. That's Judy's information. Ida, she has $172 and is spending at a rate of $4 per week. And the question we're to answer is, after how many weeks will each of them have the same amount of money? So this is a system of equations type of a problem where Judy's starting rate, she started with $20 and it's growing by $6 per week. And Ida, she starts with 72, but she's spending $4 per week, so that's a -4 times every week. And we got to make X be the number of weeks and Y will be the total amount that she has. So we're going to use the equal values method here. We're going to say if Y is equal to 6X plus 20 and Y is also equal to -4X plus 172, then 6X plus 20 must be equal to -4X plus 172. So the first thing I will do is add 4x's to each side to get rid of the 4x's on the right because we want to solve for x. That gives us 10x's on the left. And then I will take away 20 from each side to clear out the constant on the left side, and that's going to give me 152. So when you divide 152 by 10, technically x is a decimal number. So it's actually not going to be after 15 weeks before they have the same amount of money. It'll actually be in that week, between the 15th and the 16th week, when they have the same amount of money. They did not ask us to determine what that amount of money would be, so we can just declare our answer here and be done with it. All right, and then I believe this is the last problem, right? Yes. All right, so adding and subtracting positive and negative fractions and mixed numbers. We got to remember to get common denominators, and I also recommend in the problems where you are subtracting with negatives that we do KFC. So change this problem here, problem A, to read -3/4 plus -2/5, and then determine what your common denominator will be. And rewrite this as -8/20. This will be -15/20. So then when you add them together, you get -23/20, which can be rewritten as -1 3/20. Okay, so I am not going to go over and do all of these. If you wish to have me show the work on any of these that you're getting wrong or that you don't understand, your job is to let me know, let me work it out with you. Okay, I can send you an email, I can send you a video, we can get onto a Google Meet, we can talk about it, we can talk about it during class, and I can work it out for you during the time when I'm going over this homework. But please, please let me know if you need any help on this, because it's really important. These are the basics of elementary math. We need to be able to go to high school and know how to deal with fractions and decimals, positives and negatives. All right, so that ends today's homework. Let's move on to the next activity.
Hey, feeling good, like I should. When in dark, I walk around the neighborhood. Feeling